One of the greatest thrills of attending an air show as it thunders above the crowd. Hi, I'm John Nicholson. The engine punishing conditions. Cargo flying is a good example of high-use punishment, and that's why recently engines based for over 170 cargo aircraft. This fleet of hard-working Lycoming flight achieved the best performance possible from these engines. Using Shell products is an important part of the answer. And during this video presentation, the professionals will show you how to achieve that optimal performance, or full TBO, from your new or replacement aircraft engine. So let's meet the experts. Ben Visser has been with Shell for over 30 years, working on the research and development of fuel and lubricants. He's the man who can answer the important questions about aviation lubricants. Paul McBride, who began his career at Textron Lycoming in 1963, is a third-generation employee. His knowledge of piston-driven aircraft engines is the result of years of hands-on experience. John Hazlett is the Vice President of Maintenance and Director of Operations at Ameriflight Incorporated. John's team has been able to achieve 99.87% reliability of their aircraft by adhering to the methods that will be demonstrated to you during this presentation. So, what are we hoping to learn from this video? Keep in mind that we'll cover three major areas of aircraft engine care: engine installation, startup and break-in, and maintenance and normal operating procedures. From time to time, you'll see a blinking number in the corner of your screen. These numbers will help you locate information within this presentation. Just fast forward or rewind to find a topic. On the back of the video sleeve is a quick topical reference guide. But now, let's listen to the experts as they supply informative details on how to ensure full performance from your aircraft engine. Here's Paul McBride from Textron Lycoming.
So, as a pilot and new engine owner, you should get familiar with the procedures that will keep that engine flying in peak condition. That is, what to look for during the installation of your new or rebuilt engine, how to handle the initial startup and break-in, as well as executing proper maintenance and normal operating procedures. Let's focus on the installation. It would be so easy if we could just bolt the engine onto the airframe and place the aircraft back into service. But crucial elements need to be considered when installing a new or reconditioned engine. Instrumentation, baffles and seals, the oil cooler and air filter and their associated hoses are important parts of the overall system. Many high-use aircraft had their engines overhauled 2, 3, or more times, yet still retain the original gauges. For instance, a tachometer with a 5 to 10% error in calibration will greatly increase the load on the propeller and the engine bearings during operation. The cylinder head temperatures and exhaust gas temperatures are indicators of change in the engine. For high-performance engines, these indicators are critical when setting the mixture or monitoring the condition of the engine. So the tachometer, EGT, oil temp, and CHT gauges should be calibrated at this point and not overlooked. Be sure to use the most recent printing of the appropriate service bulletin. But what about oil temperature during operation? Is it too hot? Not hot enough? Ben Visser has the answer.
I bet you didn't know that a thermometer and a permanent marker can help you maintain an aircraft engine. But they can, and here's how it works. You need to make a reference mark at 180 degrees Fahrenheit on the face of your oil temperature gauge. This is a good target temperature for your engine oil. You should be aware that the typical green band on an oil gauge starts as low as 120 degrees and goes all the way up to 245 degrees. That's a pretty wide range. On most Lycoming engines, a cruising oil temperature significantly below 180 degrees won't boil off moisture present in the oil. This is especially true during a short flight. At the hottest point in a naturally aspirated engine, the temperature is about 50 degrees higher than the oil in the sump. So, if your oil temperature reading is only 150 degrees, the hottest oil in your engine is just 200 degrees, well below the 212 degrees needed to boil off the water in the system formed from condensation. The result is water and acid buildup in the crankcase, which could lead to rust and corrosion. Moreover, if your aircraft is based in a humid climate and only flown occasionally, the chance of corrosion increases. We do not recommend that you ground run an inactive aircraft. A short ground run is insufficient to get the oil temperature to 180 degrees. Now, on a turbocharged engine, the highest oil temperature is usually 70 to 75 degrees higher than the sump. In this case, we want to keep the oil temperature down to around 180 degrees. This will help reduce engine wear and deposit buildup. That's where the thermometer and marker come in. Take your oil temperature sending unit and a reference thermometer and place them in a steel container filled with oil. With a hot plate, heat the oil to 180 degrees and mark your gauge. Even if your gauge has temperatures printed on the face, checking the accuracy is worth your time. So, make that mark at 180 degrees and extend the life of your engine.
We'll learn more about checking oil, oil pressure, and oil coolers later. But baffles and seals are the next item on our checklist. Let's see what Ben's cooking up now.
Here's a baffling problem that is often overlooked. It involves the baffles and seals of your aircraft. Both are critical to cooling your engine. When an aircraft is flying, air enters the cowling and creates static pressure above the engine. This pressure forces air down through the cylinders and across the oil cooler to lower pressure areas below and behind the engine. From here, the air is sent out through the flaps or other flaring openings. If your baffles are broken or misshaped, the deformity can increase the volume of air passing a particular cylinder or other area of your engine. Since the engine is dependent on a fixed amount of air, the result is a decrease of airflow to the other cylinders or to the oil cooler. Seals can create similar problems. If your seals aren't in good condition or improperly adjusted, they'll allow air to bleed out. This reduces the static pressure, which can increase temperatures. So what can you do? Have baffles checked while the engine is being serviced or before installing a new engine. The seals should be checked during periodic inspection. If cylinder temperatures still seem abnormally high to you, check all the seals for fit and condition. If the seals aren't soft and pliable, replace them. You can check the fit of your seals underneath the cowling. I like to look at the area where the seal and cowling rub together. You notice here on this side is one continuous line where it's rubbing, but along the top you can see that it is not a continuous area, and you can see where there are leaks. Here it's been rubbing. Here you can see where the air has been leaking out, which would reduce the static pressure above the engine. Inspect the holes at the rear of the cowling for excessive leakage as well. If your cylinder head temps still run hot, you may need to have the static air pressure above the engine checked during flight. This spec should be available from the airframe manufacturer. So keep your baffles and seals in good shape. It's a simple way to keep your cool.
And speaking of cool, an important focus point on your new engine is the oil cooler, hoses, and lines. If your engine is equipped with a remote oil cooler that hasn't been reconditioned during the overhaul, be sure to flush it out or replace it. This is critical if you had mechanical problems with the previous engine that could have left metal in the system. However, flushing alone may not get all the metal out. These metal particles could damage your new engine. One complete time between overhaul or TBO cycle is the normal life of many oil system hoses, so replace those as well. Remember that the oil cooler system must maintain oil temperatures within the specified limits shown in the applicable Textron Lycoming operator's manual. This is also a good time to check the air cleaner and associated hoses. If there are breaks or cracks, this can allow dirt to be sucked up into the engine, which greatly increases the wear rate. So what have we learned? New or reconditioned engines will perform better over a longer period of time with just a little help. Calibrate your instrumentation, check the baffles, and replace the seals if necessary. Flush out the oil cooler and hoses, and look over your air cleaner system. Replace those hoses if you notice excessive wear or cracks. And remember to consult the latest revision of the manufacturer's documents.